All right, so this is one of the live sessions I'm doing this week. This is on linear equations and two variables. The stuff I'm going to do today is going to be very helpful for working on the discussion, in addition to just understanding the material. So we need to start with the rectangular coordinate system and understanding how we graph stuff. So the system that we use to graph is called the rectangular coordinate system. It's called that because basically when we form rectangles when we make points. It's also called the Cartesian coordinate system. That is after René Descartes, who's a philosopher and mathematician. So we have basically a grid, and we have what's called the horizontal axis. These are called axes. So the horizontal axis is X, and then the vertical axis is Y. If you have trouble remembering which one is which, remember Y is up. Y is up, the Y is the one going up. So the point in the intersection between these two lines, these are basically number lines, is called the origin. And then we divide it into 4 quadrants. And we start in the upper right, which is called quadrant 1, and then we move counterclockwise. In parentheses there is the X value and the Y value. So these are X first and then the Y. And it's telling you whether the value is positive or negative. So if you're looking at the horizontal axis and you ignore the vertical, you have a number line, and 0 is in the middle, and we have positive to the right, negative to the left. So you've seen number lines before, so we're building off of that. The vertical axis is then just rotated. Positive is up, negative is down. So if you think about it in terms of elevation, everything we measure, like the height of a mountain, that's all positive, and that's high, it goes up. And then things below ground are usually negatives. So that's the basis of the rectangular coordinate system. So the points in this system are named using ordered pairs because you get a pair of numbers and they're ordered X, Y. It goes in alphabetical order. So the X value is always the first one, the Y value is always the second one. And when we plot points, we always move horizontally first and then vertically. So I have some examples here, and you can see how they form rectangles. So the middle is 0, 0, and then 2 3s, you move right 2 on the X, and then you go up 3 on the Y, and then that's where you get your point. So you always read the X value first and then the Y value. Sometimes you have to estimate like the negative 1.5, negative 2.5. So this brings us to linear equations in two variables. So we've been looking at linear equations before, but everything we've looked at has had one variable. So now we're adding in a second variable. So a linear equation creates a line when it's graphed on the coordinate plane. Hence, that's where we get the word linear. It has the word line in there. So when you graph these, you get lines. An equation that can be written in the form ax plus by equals c is called a linear equation in two variables. And it's also called the standard form of a line. So if you have an equation and you have an x and y on the same side, that when you graph it will give you a line. And that is standard form of a line. So, oh, I forgot to write the equation here. Hold on. Let me see. What is the equation that I meant to write? Oh, boy. Let me just move this off. Okay, so my equation that I meant to have there, 2x minus 3y equals 6. Okay, so 2x minus 3y equals 6. It would help if you have the equation. So that is in standard form. We have x and y on the same side, and so this is going to graph a line when we graph it. So we're going to start by completing the table and then graphing. Now there's not enough room to do all the work on this slide, so I have a second slide where we're going to do the work, and then I'm going to come back and do the graph. So I'll just move my next slide to 2x minus 3y equals 6. Okay. So the table is giving us x and y values. So the first row, it has a number of 0 in the x column. So that is telling us that x is equal to 0. Second row, the 0 is in the y, so it's giving us y is equal to 0. Third row, it's telling us y is equal to 2. And then the fourth, x is equal to negative 6. So what we're going to do to find the missing value is to plug in these numbers and then solve for the other variable. So I'm going to start with x equals 0. So I'm going to replace x in our equation with 0. So that gives us 2 times 0 minus 3y equals 6. So 2 times 0 is 0. So that gives us minus 3y equals 6. So to solve this, we are going to divide both sides by negative 3. So you can see how these go back straight back to linear equations where we're just solving for a variable. We get y equals, and 6 divided by negative 3 is negative 2. So the missing number is negative 2. And so I'm going to just go back to my other slide and write that down as well. Okay, so now the next one we have is y equals 0. So y equals 0. I'm just boxing these so you can see what I'm plugging in. So you have to be careful because that's y. So now I'm not plugging in for x, I'm plugging in for y. So I'm replacing y with 0. So that's 3 times 0 there. So negative 3 times 0 is still 0, so we end up with 2x equals 6. So then I want to divide both sides by 2 because this time I'm solving for x. We get x, oops, I wanted to change back my color, I'm trying to be consistent. X equals 6 divided by 2 is 3. So the missing value in the table is 3. So I'm going to go back, put in 3. Okay, next we have y equals 2. So I'm going to replace y with 2. So I have to do my multiplication first. Negative 3 times 2 is 6. So that's 2x minus, well, that's a negative 6. So it's 2x minus 6 equals 6. And I need to solve for x, so I'm going to add 6 to both sides. We got 2x equals 12. So now to solve for x, I want to divide everything by 2. We get x is equal to 6. So I'm going to put 6 in the table. And then go back to my other one and put in that 6. And now the last row we have x is equal to negative 6. I'm going to just put this up here. So now we're plugging in negative 6 for x. So that's going to be 2 times negative 6 minus 3y equals 6. So I have to do my multiplication. 2 times negative 6 is negative 12. So I have negative 12 minus 3y equals 6. So now I'm solving for y, so I need to add 12 to both sides. That gives us negative 3y equals 18. Then I need to get rid of the negative 3, so I'm going to divide both sides by negative 3. And that gives me y is equal to 18 divided by negative 3 is negative 6. It's definitely blending in. Let me just switch to black so you can see that. So I'm going to put -6 in on my table. And then I'm over here also plugging in -6 into the table. So these are ordered pairs. They're not written in order pairs with commas, but in table form they still mean the same thing. So I'm going to start at the origin, and I start at 0. So my x is 0, which means I'm not moving left or right. And then my y is -2, so I'm moving down to -2, and then I put a circle. So now that's all right. So since I have to re-record this, where apparently I left off was in graphing. So I'm on the graphing screen, and so with these order pairs we have, we're going to just graph these 4 points. So we're going to go row by row. So the first row, we have x equals 0, so we start at the origin, and then 0 means we don't move left or right. And then y is -2, so I move down to -2 on the y-axis. Then from the next point, I start at the origin again, and my x is 3, so I move right to 3. And then I'm at 0 on the y, so I'm not changing anything on the y, so that's where my next point is. Then I'm at the origin. I go to 6 on x, and then from there, I go up to 2. So I make a point there. And then for the last point, you start at 0, you go to -6, and then down to -6. And it's important not to just count tick marks, because sometimes these things don't, they're not counting by ones. Sometimes things count by 1/2 or 2. So you want to actually pay attention to the actual numbers. So once you've done that, then you want to draw your line. I'm freehanding this. When I recorded this yesterday, I had a ruler. It's not too bad freehand. So when you connect all of your dots, it should form a line. If it doesn't, that tells you you made a mistake somewhere with your ordered pairs, and usually you can kind of figure out which one doesn't sort of fit in with the line. So because this is a linear equation, we have 2x minus 3y equals 6. This does form a line, and that's how you can verify your solution. You can also graph this in Desmos. The way you do that is when you open up Desmos, you just literally type in the equation, you hit enter, and then you would type in your ordered pairs, parentheses 0, comma, -2, parentheses, and hit enter. And you can do that for each of your ordered pairs, and you can verify that they are all on your line. And that's another way to double check your solution. Okay, so now let's talk about the slope of a line. So slope is a number that measures how slanted the line is. This is different from the angle of a line. So slope is not the same as the angle. These are two different measurements. A positive slope means the line heads up as you move from left to right. So every time we look at graphs, we read them from left to right. So the graph that we just plotted, that has a positive slope. There could be different steepnesses of these, but overall it's positive because it's increasing as you go from left to right. A negative slope means you go down, so it decreases as you move from left to right. And so this is why it's different from angles. Angles are always positive. A slope of 0 means there's no slant, so that means it's a straight horizontal line. And then a slope that is undefined is vertical. It has infinite slant. And so there's 4 different situations here to determine what your graph is going to look like based off of the slope. You've got a positive slope, negative slope, 0 slope, or undefined slope. So we write slope using the letter M. And so I've got the formula here at the very bottom. And you think of slope as how much it rises over how much it runs or moves to the right. This is, in other words, the change in y over the change in x. So how much it changes in y between 2 points divided by how much it changes in x between 2 points, the same 2 points you're looking at. And then mathematically, that translates to the difference in the y values and x values of the ordered pairs. So that's y2 minus y1 over x2 minus x1. So just a note about the subscripts. So if we have like m1, that is a subscript, not an exponent. And so when you're typing these, you would type it as m underscore the number 1 to indicate subscripts. The caret button is used for exponents. So it's a different symbol when you're writing a subscript. And these are labels. So subscripts are labels. We're just labeling these things. So when we say, and the formula y2 minus y1, that's y of the second point minus y of the first point. So the 1 and 2 represent the first point and the second point, because you need to have 2 ordered pairs to figure out the slope between them. So we can, if we have 2 lines, we can check whether they're parallel by looking if they have the same slope. So the slope of one, m1, will equal the slope of the other, m2. So parallel lines have the same slope. They have the same slant, which means that they will never intersect. 2 lines are perpendicular if their slopes are negative reciprocals. So what that means is that they are the opposite sign and they are reciprocals. So one has to be positive, one has to be negative, and then they are reciprocals. If you multiply those 2 slopes together and you get -1, that means the lines are perpendicular. Slope is also called rate of change. So you'll see that in a lot of word problems because it won't say find the slope, it'll say find the rate of change. That's just saying how much something is changing. So anything that is a rate, miles per hour, dollars per ounce, dollars per hour, those are all rates and those are all considered slopes. Basically, the slope is a way to think how much are we increasing with each step that we take. So that's how we measure the steepness. The higher a number, the more you're increasing. So that means it's going to be a steeper line. And then the negative means you're decreasing more. The more negative the number is, then the steeper it is, but in the down direction because you're decreasing faster than you might be moving over. So I've got 2 examples here just to practice these concepts. So find the slope of the line that passes through -5, 4, and -11, 12. So my first step is to label these points so that I know which one's x1, y1, and which one's x2, y2. It doesn't matter which one you label, but I usually just go in order. So x1, y1, x2, y2. So our order pairs are always in alphabetical order, x, comma, y. So the first point's always going to be x. The second one in the pair is always going to be y. So our slope formula is m equals y2 minus y1 over x2 minus x1. So now I'm going to plug in these numbers. So y2 is 12 and y1 is 4. So I have 12 minus 4 on the top. Then x2 is -11. And then x1 is -5. Because I'm subtracting a negative, I'm going to put that in parentheses there. It's really important that you're subtracting these in the same order. If you mix it up and you subtract the y's in a different order than the x's, then your value is not going to be correct. So now I'm just going to simplify by following the order of operations. 12 minus 4 is 8. And we have a -11 minus a -5. So that's -11 plus 5 for those of you who are, still are a little unsure with negatives. Negatives are confusing. So that's 8. And then -11 plus 5 is -6. Now I need to reduce that. I got a fraction. This doesn't divide into a whole number, so I need to reduce. And I can divide both of these numbers by 2. So I'm going to do that to reduce. That gives me 4 over -3. And that is my slope. So we have a negative slope, which means that the line is decreasing. So this is going to be going down as we move from left to right. Now the second one we have here is given M1 equals 2/3 and M2 equals 3/2. Are the lines parallel, perpendicular, or neither? So parallel lines, your M1 is equal to M2. These two slopes, we have 2/3 for one of them, and that is not the same as 3/2. Our slopes are not equal, so it's not parallel. That's pretty easy to tell just by, are they the same number? No? Okay. Perpendicular lines, those you multiply the slopes, M1 times M2, and you get -1. So let's do that. So M1 is 2/3, M2 is 3/2. So we just put a question mark there. Or do we get -1? So 2 times 3 is 6. 3 times 2 is 6. And 6 over 6 is 1. So we get 1 instead of -1. So that means it is not perpendicular. So because our lines are not parallel and they're not perpendicular, that means the answer is neither. It means they will cross at some point, but not at right angles. Now here's a word problem, and this is more where you will see slopes used in real life. And a lot of you work with slopes and you don't even know it. Any job where you're getting paid hourly, that's a slope. Your salary or how much you're making, that can be an equation of a line. So a lot of real world things are lines, even if you don't know it. So in 1985, the U.S. Postal Service charged 22 cents for first class letters and cards up to 1 ounce. By 2015, the price had increased to 49 cents. Let X represent the year and Y represent the cost for 1 ounce of first class postage. Find the average rate of change of the cost per year. So rate of change, I said, is slope. So we're looking for the slope. And that word average is in there because the amount that stamps increase every year is not the same, but using the beginning point and the ending point will give you an average. So your slope formula for real world data is actually finding an average. So because real world data doesn't have a constant increase, because we're not increasing by the same amount. So that means thus the slope is the average. Or the slope gives an average. So what that means is sometimes it might decrease or might increase less than the slope. It might be bigger than the slope, but on average, that's what it's going to be. So first thing in order to get the slope is we need to figure out our ordered pairs. So the way things work is you're usually, I shouldn't say usually, basically always, your time is always your X value. And they tell us here, X represents the year. And then Y is the cost. So that means the first ordered pair is going to be the year. So I'm going to start with 1985. And then the cost associated with that, 0.22. And then the second pair they're giving us, the year is 2015. And the cost there is 49 cents. So I'm going to grab my calculator because we're going to be needing it here since we're involving decimals. So I'm going to just label this X1, Y1, X2, Y2. And then I'm going to write my slope formula, which is Y2 minus Y1 over X2 minus X1. So I'm going to plug in the numbers. So Y2 is 0.49 and Y1 is 0.22. x2 is 2015. x1 is 1985. So now I need to do the subtraction. 0.49 minus 0.22 is 0.27. And then 2015 minus 1985 is 30. So this is telling us that the price increased by 27 cents over 30 years. So that's the total increase. When we divide it by 30, it's giving us an average per year. So we never have our answers with a decimal in a fraction. So we need to actually divide that out. And so that gives us 0.009. Now, because this is real world data, this has units. We start on top, that's price. So this is dollars, and then the division is basically per. So this is dollars per, and then we're dividing by year. So we can write this as $0.009 per year. So, and it's positive. So the price increases on average by barely a cent each year, which is really cheap, actually. That's really, really cheap. So whenever we have word problems, we always want to write our answer in a final sentence because you want to put it in context. Anything in real world problems, any word problems, they have to be answered in context, not just a number. So we would say the average rate of change is $0.009 per year. And you can give it more context from there, saying the average rate of change of the cost of first class postage, but just enough so that you're saying, okay, this is the slope or the average rate of change, and then this is it, and then this is the units there. So it has some context to your answer. You're not just giving 0.009. So now that we have an idea of slope, next is the form of a line, basically the different equations for lines. So we've seen standard form of a line, which is ax plus by equals c. But there are also two different forms. So standard form is not used often. That is mostly used when you're solving systems of equations, which is something that you'll see at the very end of college algebra, and then cover in more depth in pre-calculus. Most of the time, you either see what's called slope-intercept form or point-slope form, and both of those formulas are here. So slope-intercept form is y equals mx plus b. I'm sure you've probably heard of that. So of course, m is the slope, and b is what's called the y-intercept. And the y-intercept is where we cross the y-axis, and we do that where x is equal to 0. So that actually gives us an ordered pair, 0, comma b. So if you're given any ordered pair where your x value is 0 and you know what your b is, you're given a y-intercept. So slope-intercept form gives you the slope, and it gives you 1 point from there. Point-slope form, you have a slope, and you also have 1 point, but it's a different point. You have a y1 and an x1 in there, and that is your point. So for both of these, you have 1 point and 1 slope, but the points are different. Slope-intercept form gives you specifically the y-intercept. Point-slope form can be used with any point. And depending on what information you have, that sort of depends on, decides which of these forms you're going to use. So I'm going to start with an example, write the equation of a line with a slope of -4 and point of 4, 3. So this example and the next example I have are going to be helpful for when you're working on the discussion. So here we're given the slope. So m is equal to -4. Next is the point. So we're given a point, and I'm going to just label that x1, y1. So x1 is 4, y1 is -3. So we have two forms that we can use. We're not given a value where x is 0, so we want to use point-slope form. So I'm going to start with writing that equation. Y minus y1 equals m. Actually, I'm going to move this up. y minus y1 equals m times x minus x1. So I'm going to start by plugging in my numbers. So y minus, and then y1 is -3. So every time I subtract a negative, I'm going to put that in parentheses. So that equals m. That's our slope. That's equal to -4. And then I have x minus and then x1, which is 4. So now I've put this in point slope form, but most of the time when we look at equations, we have it solved for y. So I'm going to show you how to do that. So the first step is on the left, I need that minus and negative. I'm going to simplify that. Subtracting negative is adding, so that's going to be y plus 3. And then I need to distribute through the parentheses on the right side in order to simplify. So that gives me -4x, and then -4 times -4 is a positive 16. So I'm solving for y, which means I want to get y by itself. So I have this plus 3 on the same side as the y, so I'm going to subtract that. And I want to make sure I subtract it from its like term, which would be the 16. So that gives me y equals -4x, then 16 minus 3 is 13. And that is our equation for a line with a slope of -4, and it has a point 4, -3. And if you graph that equation in Desmos, and then you graph, or you plot the point 4, -3, you'll see that it goes through that point. And then when you solve for y, we got some extra information here. We have a b, because this is now slope-intercept form, of 13, so that means we have a second point is 0, 13. So we got a second point out of our equation. Now this example is more similar to what you have to do because we've got to create the slope. We have write the equation of line with points 4, -8, and 0, -4. And we need to create the slope between these 2 points before we do anything else to get the equation. So I'm going to label these x1, y1, x2, y2. And so I'm going to start writing my equation for slope, which is y2 minus y1 for x2 minus x1. And we had to find the slope because both of these equations for a line require the slope as part of the equation. So you can't do anything until you know what that is. So y2 is -4, y1 is -8, x2 is 0, x1 is 4. So on the top I have -4 minus -8, so that's -4 plus 8. And then 0 minus 4 is -4. When we do -4 plus 8, that gives us 4. So we have 4 over -4, which divides to -1. So our slope here is -1. So now we have a slope. And one of our points that we're given is actually the y-intercept because the x value is equal to 0. So since we have a slope and the y-intercept, we can use slope-intercept form. So that is y equals mx plus b. So our m is -1, so that's -1x plus, and then the b value is the y value, which is going to be our y2 here. So that's -4, because the x is 0 and the y is -4. So we get y equals -1x plus -4, or you can write -4. Now, if you're curious, what would happen if you'd use point slope form? Well, you'll get the same answer. So I'm going to do that in a different color. So I have y minus the y1 is -8. So I have to have that in parentheses. M is -1, then x minus the x1, which is 4. So simplifying, subtracting negative is adding, so that's y plus 8. And then I distribute on the right, so that's -1x plus 4. Then to solve for y, subtract 8 from both sides. We get y equals -1x, 4 minus 8 is -4. So we get the same answer if we use point slope form. So you can use either one for this particular example. For our problem in the discussion, you're not going to be given the intercept because that would require somebody to have a forearm length of 0, which is not possible. So you have to use point slope form for our discussion. So if you have any questions, of course, you can email me or give me a call or send me a Hangouts message. And I look forward to working with you guys again.